Welcome everyone. So let's go ahead and take a look at this example. This problem involves creating probability distribution table, and then we're going to find the expected value of this game, and also we'll determine whether the game is fair or not. So if you haven't been introduced to similar ideas, I'll leave some link in the description box for you to check out more examples. Let's go ahead and dive in. So after paying $4 to play, all right, this information is important. A pair of fair dice are rolled, so we're going to roll 2 dice. You are paid back the number of dollars corresponding to the sum of the number of dots facing up. For example, if a sum of 5 turns up, then you're paid $5, which means your profit is $1 because you paid $4 to play the game. If the sum of the dice turns up 3, then you're paid $3. That means you just lost $1 for that game. We want to know what is the expected value of this game. All right, so now also keep in mind that for a game to be fair, we're going to assume that the expected value of this random variable x must be 0. So let's go ahead and see what's going to be our probability distribution for this example. So first thing we're going to write down is our sample space. So we're going to roll 2 dice. So here's how the sample space will look like. We'll create a table like this. So this is our sample space. Call it S. So let's call this 1 die. So let's horizontally we'll list all the outcomes on one of the dice. So 1, 2, 3, 4, 5, 6. And vertically we'll write down the outcomes for the other die. So I can also get 1, 2, 3, 4, 5, and 6. So let's write them out. All right, so if I roll them, I can either get 1 on the first, 1 on the second, or I can get 1 on the first, 2 on the second, and so on. So that's how you list them. Now, since we're only looking at the sum of the dice, sum of the dot on the dice, instead of writing 1, 1, I'm going to write their sum. So for this outcome, I could get the sum to be a 2. For this outcome, I can get a sum to be a 3. And so on. So that's how I'm going to create this distribution. So here the sum is a 4, this is a 5, this is a 6, this is a 7. And you just go on and continue creating all of these possible sum you can obtain from this experiment. So here the sum could be a 3, this is 4, 5, 6, 7, 8. And here we could get the sum to be a 4, 5, 6, 7, 8, or 9. Again, if you're confused, this is by getting 6 on one of the die or 3 on another die. That's how we get the sum to be a 9. Keep going. So this is a 5 or a 6, 7, 8, 9, 10. Then here we could get a 6, 5, or a 1. That's a 6, or a 7, 8, 9, 10, or 11. And let's fill in the last row. Either the sum could be a 7, 8, 9, 10, 11, or 12. So this, again, you're getting it by getting 6 on one of the die and 6 on another die. The sum is a 12. All right, so now that we have the sample space out, we know there are 36 outcomes. So we know that the number of outcomes in our sample space is 36. So now we can start writing down our distribution and see how it looks like. So our random variable x is going to stand for the possible payoff amount or net gain. So let x stand for payoff amount or the amount of net gain. So x can take values such as, so if the sum, so the lowest value you can get is a 2, the sum is a 2. So since you're paying $4 to play, your lowest net gain will be negative $2. So you'll lose $2 and then it will start to increase. And the maximum you can get is the sum to be at 12, meaning your possible net gain will be 12 minus 4, that's $8. So that means x can take values of -2, -1, either 0 meaning you roll this possible outcome. So you roll 2, meaning the sum is a 4. So you get $4 back, net gain of $0. So hopefully you get the idea what are the values of x. So all the way up to 8. 8 will indicate that the sum is a 12. So I hope you understand this. Let me create the distribution now. So here's our probability distribution of X. We create two rows like this. That's for X, and this is for probability of each X value. So like we said, we can either have a net gain of $2. What that means that you roll the sum. So this will mean the sum of the dice is a 2. So if the sum is a 2, since you pay $4 to play, you lost $2. Or you could have a net gain of the sum to be a 3, so you lose $1. So this would indicate that the sum here, you got 3, and so on. So hopefully you have an idea what's going on. Or we could get net gain of $0, the sum is a 4, or $1 if sum is a 5, $2 if the sum is a 6, and so on. So 2, 3, 4. We're going to have to do all the way up to 8. So 5, 6. All right, 2 more column to go. 7 and 8. All right, so what this, the last outcome, this will mean that your sum is a 12, and so on. Okay, so now let's find their corresponding probabilities. Now, what is the probability of getting the sum to be a 2? Well, we know that the sum is a 2. This is the only outcome, which is 1 out of the 36 outcome. So we know this probability is going to be 1 out of 36. Now, what about the next one? The sum is a 3. Your expected return is a negative $1. The sum is a 3 is here and here. So that's 2 outcomes out of 36. This is 2 out of 36. Now, for the X value 0, we know the sum is a 4. So the sum is a 4 along this diagonal. And this is 3 of them. So 3 out of 36. So hopefully you get the idea where this is going. Now again, for X equal 1, that means the sum is a 5. So 5 is right here. Sorry, not that. Right here along this diagonal. There are 4 of those outcomes. So that's 4 out of 36. So you see that this is 4 out of 36. And what about the next one? You get $2 returned. That means the sum is a 6. So the sum is a 6 is right here. These are the ones. And we have 1, 2, 3, 4, 5 of them. So this is going to be 5 out of 36. And what about $3 in return? That means the sum is a 7. So the sum is a 7 along this diagonal. And you got 6 of those. So this is going to be 6 out of 36. You can simplify that at 1/6. Now, for these missing probabilities, you'll see that those are pretty much same as these guys right here. And if you don't see that, you can again work it out. How do you get $4 in return? Well, if the sum is an 8. So the sum is an 8 along this diagonal. So that's 5 of those out of 36. So this is 5 out of 36, which is same as this one right here. And then the sum is a 10. This is going to get you the next return, and the sum is a 9, and so on. So if you fill this in, you'll see that this will give you probability of 4 out of 36. This is going to be 3 out of 36. This is 2 out of 36. The last one, believe it or not, it's going to be 1 out of 36. Or you can see, how do you get $8 in return? If you get the sum to be a 12. So there's only one outcome out of 36. So that's 1 out of 36. So the distribution since looks symmetrical after this possible X value. Okay, all right. So now we know that some of these probabilities must be equal to 1. You can check that and you'll see that it's equal to 1. Now that we have the distribution, let's go ahead and find its expected value. So we know the expected value of X. It's simply taking each X value and multiplying by its corresponding probability. And we add them up. So the first X value is -2. Its probability is 1 over 36. The second X value is right here. That's going to be plus -1 over 2 over 36. The next X value is right here. This is going to be plus 0 times 3 over 36. And you do the same thing for all of them. The next one is 1 out of 4 over 36. And then the next one is a 2 times 5 out of 36. Sum up to this one. Now the next one is this, 3 times 3 over, no, I'm sorry, 3 times 6 over 36. The next one we got is 4. So the next one is this x value times its corresponding probability, 4 times 5 over 36 plus 6 times 3 over 36 plus 7 times 2 over 36, and the last one 8 times 1 over 36. So carefully put them in your calculator and you'll have an expected value of 3. In other words, $3. So our expected value of this game is a gain of $3. Okay. All right, so that is the first part of the question. I hope this makes sense. Then the next part is to determine whether it's a fair game. Well, since for a game to be a fair, we want the expected value to be 0. Since we got a 3, we know that this is not a fair game. So we'll call it not a fair game, since the expected value of x didn't equal to 0. All right, I hope this makes sense. I'll see you next time. Take care.